In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N respectively, and the segments intersect at point M as shown. If the circumference of the circle is 96, what is the length of minor arc LN? So we're looking for the length of this arc right here. So because every question on the SAT has a concept, this one already speaks for itself. It's the length of an arc. And thankfully there's a formula for arc length, if you may remember. It's always the angle that forms that arc over 360 times the circumference, which is pi d, or 2 pi r if you prefer. Thankfully we are given the circumference this time, so we already know that pi d really for you and I is going to be 96. How do we know this? The circumference of the circle is 96. So we have a bit of a problem. We don't know what arc length is. That's what the question is asking for. And we also don't know theta, which is the angle here that forms this arc. So our first goal to be able to answer this question would be to find this missing angle right here. So to be able to do that, we were given clues. In geometry, remember, we based everything off of like theorems or postulates. We were told that line segments LM and MN are tangent to that circle. So here's LM right here. And if a line is tangent to a circle and it so happens to intersect or meet with a radius or even a diameter, they automatically form a 90-degree angle. That's a fact. And MN is the same way because that's a tangent and it's meeting with a radius. So we also know that this is also 90 degrees. So the only angle that's unknown, the central angle here, let's just call it X. Now we have a quadrilateral known as OLMN. Quadrilateral means four-sided, and if you have any four-sided figure and you added all the angles together, it will always add up to 360. So we can set up a little equation based on that. If we took L, which is 90 degrees, plus angle M, which is 60 degrees, plus angle N, which is 90 degrees, plus the unknown central angle of X, those should add up to 360. So when we add these together, we have 90 plus 60 plus 90 becomes 240, plus X equals 360. Subtract 240 from both sides, and we end up with an X value of 120. So we then now know that our central angle here is 120 degrees. We needed that, so we can plug it in to here and we'll find the arc length LN. So let's go ahead and do that. So to find our arc length, which is LN, arc LN, it's going to be 120 over 360 times the circumference, which is already given to us as 96. Thankfully, this 120 over 360 simplifies to 1/3, and 1/3 times 36 is also very doable because 96 is divisible by that 3, and it's going to be 32. So the length of arc LN is 32 units, and that's it.